Hello, now I'm going to discuss about JK flip-flop. So here we are considering positive age triggered clock pulse. So when this clock is going to change from 0 to 1, then flip-flop will be triggered here. Now we'll take different combination of J and K and we'll try to verify the truth table, how we got this truth table, what we have written here. Initially, if you see that if we are going to take J as 0 and K also as 0, and when clock has transition from 0 to 1, then this clock is going to give input as 1. Now we have J is 0, due to clock it is 1. K also we have taken 0 and due to clock it is 1. Now we are trying to verify the first row of this truth table. So here this Qn we are taking as the 0. So Qn is 0. So this here Qn dash will become 1 since it is always complement of each other. Next we are going to observe what will be the next state. So generally we are talking about output of the Q only. So we'll just see the Qn plus 1 here. So now if you see that here in case of JK flip-flop, this NAND gate, the NAND gate 1 is connected here to the Q dash and NAND gate 2 is connected to the Q. So since Qn is 0, so this input to the NAND gate 2 is 0 and Q dash is 1. So the input to the NAND gate 1 is 1. So now in this situation, you are going to see that one of the input to the NAND gate 1 is 0. So output is here 1. Similarly, for the NAND gate 2, at least one input is 0, should be 0, then output is 1. But here already we have two input is 0. So we are sure that output of the NAND gate 2 is going to be 1. Now we'll talk about behavior of this latch, which is combination of NAND gate 3 and 4. Since we are taking Qn as 0, so that 0 is going to become the input here. And so due to that, again what we are going to see that here now inputs to the NAND gate 4 is 1 and 0. So we are sure that NAND gate 4 output will be 1. Now this 1 is given here as the input to the NAND gate 3. So now both inputs become 1. So output of the NAND gate 3 is what? 0. So this first row is verified. So Qn was the present Qn, if you are considering Qn as the previous state, then Qn plus 1 is the present state. But generally we call Qn as the present state and Qn plus 1 as the next state. So here we have seen that state remained same. So same thing will occur if we'll verify for the second line also. When we'll take Qn as the 1, again we'll have similar condition that Qn plus 1 is also going to be 1 only. So like this, each and every truth table column can be verified here. So that we'll have this truth table. So basic logic behind this truth table is what? If you'll try to summarize here in few lines. So when we have J and K both are 0, 0, then whatever is the present state, Qn plus 1 will have no change. Same present state will have next state also. That is these two rows. When we have 0, 1, Then in this scenario, what we are going to see that what will be the Qn value, whether it is 0 or 1. Here, next state is going to be the 0. That will be the condition of the reset. Now, another you are going to see that if you have J and K combination as 1, 0, then whatever is the scenario, so earlier we have seen this, now we are talking about this 1, 0. So whatever is the value of Qn, either 0 or 1, it is Qn plus 1 is going to be 1 only. So that will be called as the set. And last one you have when both inputs are 1, J and K both are 1, and Qn is going to be either 0 or 1. So when it is 0, it will become 1. And when it is 1, it is going to be 0. So that will be called as the complement. So that is the scenario here in case of 1, 1. Similarly, here we have excitation table. So since here on the basis of present state and next state, we are going to see the what was the value of J and K, or what are the combination of J and K is possible. So when Qn plus 1 both are 0, J is 0. When it is 0, 1, J is 1. And for the remaining two condition 1, 0 and 1, 1, it is indeterminate states. And K, if you see that, it is the mirror image of the J. So like this, you will able to remember the JK flip-flop excitation table and JK flip-flop truth table. Already we have verified. And same can be done for by giving the all situations. So you have to keep in mind that when both inputs J and K is 0, there will be no change. 0, 1, it will be reset. Next state is going to be 0. What for the 1, 0, next state will be set, that is going to be 1. And when both value are 1, 1, then it is going to complement. If present state is 1, next state will be 0. If present state is 0, next state will be 1. That is the complement. Thank you very much.